Group 1 metals, the alkali metals. The group 1 metals are on the left side of the periodic table. Okay, and they are called group 1 metals because they all have one electron in its outer shell. So I'll just talk through them. So it's lithium, sodium, potassium, rubidium, cesium and francium as we're going down the group. Okay, so all of them, they're metals, they're soft, you can cut them through with a knife. And as you're going down the group, the melting points and boiling points are decreasing. They are low in densities. Actually, the first three, they are lower density. They have lower density than water, and then float on the surface of the water. So what are the physical properties? It is how the substance look and how does it act, but without chemically reacting with another substances. So these were the physical properties of group 1. We're going to move on to chemical properties. So how does it react with other substances? So we already know they are in group 1 because all those alkali metals have one electron in outer shell, and as going down the group 1 they become larger and larger because we got more electrons to place on those shells. Okay, but they have one thing in common: they all have one electron in outer shell, and they will lose this electron to become stable. They will lose this electron to actually lose that outer shell, so the next shell underneath is full, and that will become its outer shell. And they will form a +1 ion. By losing one electron, they will become +1 ion. Okay, let's just talk about the chemical reactions of group 1 metals. So the first ones are reactions with water. When an alkali metal reacts with water, it produces a metal hydroxide and hydrogen. So for example, if we have a sodium reacting with water, it will produce sodium hydroxide. Here, put our charge on that ion over here. So the metal ion goes from 0 to +1. As you can see, okay, it's getting oxidized. And will produce a hydrogen. So why are they called alkali metals? Because they produce a base that dissolves in a water to form an alkali solution. Okay, the sodium hydroxide is actually a strong alkali. It's got pH higher than 7. If you would put a universal indicator, it would change from green, which is neutral, to blue or purple, which is an alkali condition. So that is why they're called as well alkali metal, because they produce an alkali solution in water. The next set of reactions that we need to learn are the reaction with oxygen. So when an alkali metal reacts with oxygen, it produces a metal oxide. So for example, sodium plus oxygen, it will produce a sodium oxide. These oxides are white solids. So the group 1 metals are highly reactive. They readily react with oxygen, actually, from oxygen from the air. So normally we need to store them under a layer of oil and in airtight container. So you would take it out and cut through the alkali metal. It would reveal nice shiny sides to it. However, this side would tarnish very, very fast. It's because that metal oxides start to produce on there. Okay, and the third reaction is reaction with chlorine. Okay, chlorine is a group 7 gas. Okay, call them halogens. So when an alkali metal reacts with chlorine, it produces a metal chloride. So for example, sodium reacting with chlorine, producing sodium chloride. That is actually your salt, table salt, and we know that table salt is white and does dissolve in water. So you can remember this property quite easily. So chlorides are white solids and they dissolve in water. Okay, so now we're just going to explain that reactivity of group 1 metals, why do they react so fast? As you're going down the group, actually the reactivity increases. So we're going to explain this trend. As you're going down the group, the atoms become larger, and the outer electrons starting to go further away from the positive nucleus. And also there is a phenomenon called electron shielding, because those inner shell electrons are in the way between the positive nucleus and the outer shell electrons. So basically they are weakening this electrostatic force between the positive nucleus and outer shell electrons. And as you're going down the group, the distance between positive nucleus and the outer shell electrons is getting larger, and the electrostatic force between the nucleus and outer shell electron is getting weaker. So it is easier to lose the valence electron, the outer shell electrons, as you're going down the group. So that means as you're going down the group, they're getting more and more reactive, and that would mean that the francium is actually the most reactive alkali metal. Okay.